So, good evening, friends. Today, again, we will just go with the concept. In the last lecture, we have seen about the atomic packing factor, how that atomic packing factor has been calculated. So, once again, we will just take the review of those things and then we will just go with this next concept, that is the indexing of lattice plane, or once again it is called as a Miller indices. So these are the structures that what you have seen over here, and once again I think in the previous lecture you can be able to calculate the atomic packing factor for all the respective structures, as well as you can be able to calculate now the number of atoms per unit cell. Now this is the very important part again, and again it is very interesting. So we will just take the overview of the concept and then we will see what is the indexing of lattice directions, or it is again called as a Miller indices. Why it is called as a Miller indices? Because that has been defined by the scientist Miller, and first of all he have just put those things, that is he is the English crystallographer, and hence this particular indices of the planes are called as Miller indices. So first of all, what is the crystal structure? In the previous lectures we have just seen those things, that is the unit cell. What is the meaning of unit cell? That is the smallest repetitive volume that contains the complete lattice pattern of crystals. So basically the 7 crystal systems are there, 14 crystal lattices are there, which is shown in this particular geometry. Now what is the unit cell types? So unit cell, the 4 basic lattice parameters are there. One is called as a primitive, then face centered, then body centered, and end centered. So all these structures that we have seen, once again we are just taking the review of those things. So in the primitive structure, only the unit cell contents, okay, at the corner points 1 2 3 4 5 6 7 8, so on, only on the corner that you need that particular atoms are present. So that is the single lattice points, that is called as a primitive. So in the face centered, again on the faces, apart from the corners, on the each face the atoms are present, okay. So that is called as all the faces of the planes that composing the cells. So that is the unit cell contains atoms in the all faces. So in the body centered, okay, so in that body centered, the unit cell contains the atom centered on the sides. So on these sides you can be able to see, and end centered. So these are the some basic structures. Then the lattice parameters, basically the cubic structure is there, orthorhombic structure is there, and hexagonal structure is there. So basic definitions, once again we will take the review of this: points, vectors, and Miller indices. So these are the three parameters that you should be know for this particular lecture. So these terms will be repeated in the next particular slides. So 3 index for the cubic and 4 index notation for the HCP for the Miller indices. Now just see what is the meaning of Miller indices. So a shortened notation to describe the certain crystallographic direction and plane in a material. So just see here you are observing the axis x, y and z, and on this particular surfaces you are just observing some sort of that notations has been defined, okay. So on those notations this will be a 1 0 0, then on the upper plane it will be a 0 0 1, then on the side plane it is 0 1 0. So basically these things you are observing in this particular part. What is those things? In the latter we will go with this particular contains. So this is the point coordinating system. Now here just see, this is the x direction, this is the y direction, and this is the z direction. On this particular point the notations are given 0 0 0. On this particular point the notations are given 1 0 0. At this particular point it is 1 1 1, 1 1 0. At this particular point it is 1 half 1 and 0. and in this particular point it is 1 1 and 1. Now what it means, you just try to understand. From the origin, from just we are moving from this particular point to this point, which is in which direction? It is we are moving in the only x direction. So we are not moving towards the y direction and we are not moving towards the z direction. So just to reach this particular point, we are moving from 0 to 1, and that's why in the coordinate system that particular coordinators are written as an 100. So coordinate of the selected points in this particular unit cell. Now just see this particular point. Just to reach this particular point from the origin, we have to move from this particular point, okay, to this particular point, this to this, and then from this particular point to this. So we are moving in the x direction by the 1 and towards the y direction 1. So from this to this, the coordinate system 1 1 0. Similarly here we are moving towards x half and then towards y by the 1 unit. So this coordinate system will be 1 half, 1 and 0, because we are not moving in the z direction. So here and here the z direction coordinate are 0 0. Now just consider about this particular respective point. Now just to reach this particular point, we are moving in this way. Okay, so x we are traveling 1, y we are traveling 1, means from origin we have to reach from this to this, that is x1, then y1, and then again in the upward direction z1. So this coordinate system is 1 1 1, 0 to 1 in the x direction, then from this direction in the y direction by the 1 unit, and again from this particular point to z by the 1 unit. So this will be a 1 1 1. Now from 0 to this particular point, only we are moving in the upward direction over here or in the z direction. So we are not moving in the x direction, we are not moving in the y direction. So both the coordinators are 0, and then this will be a 1. Now why I am explaining this thing, because in the next particular terms you have to understood these things thoroughly. Now this is the point coordinates once again in this particular geometry. Now point coordinates for unit cell center are, center in the sense center of that particular geometry, it will be a by 2, b by 2 and c by 2. So this will be a point, this will be a b point, and this will be a c point. So point coordinates for the center, when we want to calculate the point coordinates for the center, it will be a by 2, b by 2 and c by 2. So it will be a 1 half, 1 half and 1 half. Now point coordinates for the unit cell for the corners are 1 1 1. So when we want to go for the each corner, it will be a 1 1 1. Okay. Now this is the for the crystallography direction. So here we are just considering about the direction. So a vector repositioning to a pass through the origin. So just consider whatever may be this particular point. Okay. So here that example it is given. So in the example it is written 1 0 half. So when we are multiplying this by the LCM, that is by the 2 term, so it will be a 2 0 1. Okay, and it has been written as an 2 0 1. So this is to adjust the smallest integer value. When it is under the some sort of that 1 half, and likewise we have to multiply by the LCM. Also for the negative direction, that is if suppose it is minus 1 1 1, that coordinates or that coordinates, then we have to write that coordinates as a minus 1, we have to write as a 1 bar. So it indicates it is the minus 1, and then the remaining coordinates, that is 1 1 1 1. Okay, so where over bar represents the negative index. Negative index in the sense what? We are moving in the opposite direction than the positive. Now this is this particular slide. Again some sort of that geometry, that is procedure it is given. How to draw any line is specified by the 2 points. So when we want or wish to draw any line, that should be, it is having the 2 points, it is just joining. When we are drawing a line, it means it is joining the 2 points. So the first point is typically at the origin we are considering, and then the second point, it is moving towards some sort of that any value in the x, y and z direction, and which is having the units or fractions of a, b, c, that is the vector projections. It is called as a vector projection, that is the length of vector projections. So when we wish to multiply or divide by a common factor to reduce the lengths of the smallest integer value, that is UVW. So includes the square, that is UVW, that is 110 directions. So just it is giving the procedure. Now we will just see the example. So this is the example how to just come up with the coordinate system. Now just see here, this will be a origin point 0. When we want to come from this particular point towards the point M, we have to travel in x direction by the 1 and in the z direction, in the y direction by half of this. So x coordinate is 1, y coordinate is 1 half. We are not moving towards any z direction, so z will be a 0. But when this is the 1, this is 1 half, so 1 half 0. So when we want to convert this terms into the integer, we have to multiply this particular thing by the 2. So when we are multiplying by the 2, so it will be a 2 1 0. Similarly for this particular part, so when we want to move from 0, this origin, towards in the upward direction, so here you can be able to see in the x direction we are moving by the half, in the y direction we are moving in the half, and in the z direction almost we have traveled by the 1 unit. Okay, so x direction, that is shown over here, this will be the y direction. Okay, then this will be a x, how much it has been traveled, because this is the x coordinate parallel to this x, so it will be a 1 half. Okay, so at 1 half this particular point it is there, and z is 1, so 1 half and 1. Okay, so when we are multiplying this particular term by the 2, okay, so it will be a 2 into 1 half, 2 into 1 half and 2, so it will be a 1 1 2. So just to convert into the integer, so might be this is clear now. Now when we want to go with the negative direction, when we write the direction n1, n2, n3 depending on the origin, so the negative directions are written as r is equal to n1a1 plus n2a2 plus n3a3. So these are the indicating some sort of that negative directions. So this is suppose the origin O, this is the y direction in the negative zone, this is the y direction in the positive. Similarly for the z it will be a negative, for the z it will be a positive. Similarly for the x, when we move in this direction it will be a negative direction for x, and when we are moving in this direction it will be a positive direction of x. So one more, some examples of the crystal directions. Now this is the origin, this will be, this particular point is 1 0 0. When we want to reach towards this particular point, that is point S, it will be 1 1 0. Similarly we have explained this particular thing. And when we want to just go with the negative, we have to shift the origin. Okay, so this is the origin shifting. And when we want to go from this to this direction, this to this, so when the origin is here, we are just moving in the backward direction of x, again the opposite direction to the y. So this is indicating by the 1 bar 1 bar 0. So that is the -1 -1 0. It is written as a 1 bar 1 bar 0. Okay. Now this is the few more examples of this particular thing. Now here the origin is shifted towards this particular point when we want to go with the reference with this particular direction. So origin is shifted from this particular to this, then we have to tell. So in the x we are moving in the opposite direction, so that is -1 with the 1 unit. Then z the direction is not changed, it is we are traveling into the positive direction. But again for the z, here why it is minus 1 by 6, because from this point to this we have to come towards the downward side. So that's, and the value it is 1 by 6. So when we are moving into the downward direction, it is indicated by the minus 1 by 6. So the coordinates are minus 1 1 minus 1 by 6. When we are multiplying by the 6, it will be a 6 bar, 6 and 1 bar. Okay, that is the minus 1 means 1 bar. So these are the crystal planes. Now it is cleared from this particular diagram. Okay, within the crystal lattice, it is possible to identify the sets of equally spaced parallel planes. So these are called as lattice planes. So what is the meaning of lattice plane? Now it is cleared. So suppose this is one particular point. This is the, to reach towards this particular point, we have to travel by the a vector. Then just from this to this, we have to travel by the b vector. And these are the parallel planes which is shown by the dotted line over here. Now the crystallographic planes, just to, we have to create some new origins, and likewise the algorithm for the Miller indices, that is read of intercepts of the planes with the axis in terms of a b c, take the reciprocal of the intercepts. This is the just procedure of the Miller indices reduced to the smallest integer value and enclosed in a parenthesis, no commas. So that is structure. So these are the 4 steps in the algorithm of the Miller indices. One by one we will clear. So just, it is a reference purpose. So now we have to go with the term of the Miller indices. Now this is one example of the Miller indices. First step, that is we have to write the intercepts 1 1 infinity for this particular thing. 1 1 infinity in the sense a, we have traveled in the 1, b again 1, and there is no any some sort of that intercepts in the c direction. So it is not meeting anywhere into the c direction, and that's why this intercept has been taken as an infinity. So reciprocal of this, that is 1 upon 1, 1 upon 1 and 1 upon infinity. This is the reciprocal of this. So that's why when we are converting that reciprocal, 1 upon 1 the value is 1, 1 upon 1 again the value is 1, but 1 upon the infinity the value is 0, because it is very smallest value. So that's why we are considering it is an 0 value. So the reduction, that is 1 1 0, and the Miller indices without any commas and all we are writing, that is the Miller indices for this particular structure is 1 1 0. Now this is the second example with this. So for the x direction, it has been moved from this particular point to this, that is 1/2. There is no any, this is the b direction, so there is no any intercepts. Just see the projection, this is along with the x axis only. So on the y there is no any some sort of that interception. So that's why for the b vector it is infinity. Again with the c, again with this plane, there is no any some sort of that interception. So that's why it is taken as an infinity. So 1/2, that is the reciprocal of 1/2, it is converted, that is 2. 1 upon infinity it is 0, 1 upon infinity it is 0. So the Miller indices for this particular is the 2 0 0. Similarly some more examples are there here. In the a it will be 1/2, for the b it is 1, for the c again it is 3/4 approximately. So the reciprocals we have taken and we have just converted, that is 2 1 4 by 3. Now reduction, it is 4 by 3. Just to reduce this particular term, we have to multiply by this particular term by the 3. So when we are multiplying this particular term by the 3, so 3 into 2 it is 6, 3 into 1 it is 3, 3 into 4 by 3 it is 4. So the Miller indices for this particular that crystallographic plane, it is 6 3 and 4. So how to determine the planes, it is shown over in this particular diagram. Now the family of planes, so that family for 1 0 0, that family it is given, that is 1 0 0 0 1 0 0 0 1 1 bar 0 0 1 0 1 bar 0. So likewise that families of some sort of that planes are there. Now from this, the family of plane 1 1 0, that whole family it is given, and the geometries or that structures are given for this particular. So 110, when we want to draw this particular plane, we have to move from this to this in the 1, then again for the y it is 1, and rest it is, there is no any interception for the z, so it is 0. So this particular plane it will be there. So just to draw 1 bar 0, again we have to shift the origin, and according to that we have to make the plane for the 1 bar 1 0. Again we have to just for the 1 bar, in the sense x will be in the negative direction, okay, and y again it is with the same. So same sort of the geometries are there for the family. So for the fc cell with a unit of 110 plane, so again 110 in the sense this is the particular plane, x direction 1, y direction 1, and there is no any interception for the z direction. So this will be the plane for FCC structure. Then for the BCC unit again 110. So for the BCC also this will be a same kind of that plane will be there. Then the example for the interceptions it is given. So intercepts points, again it has been explained, the Miller indices for this particular structure 100, and here you can be able to see this particular structure with the pink color. Okay, so that is the only the intersection with the x-axis itself. So here when the Miller index is 110, so 1 here 100, this will be a 0 1 0, and this will be a plane for the Miller indices 110. Then again the Miller indices 111 in the sense this from this particular point to x 1, from this particular y to this, that is 0 1 1 0, and from this particular point origin to z, it is 0 0 1. When we are joining this, so this kind of that plane will be there for the Miller indices 111. Then for the Miller indices 210, so this will be the example. Now how the Miller indices are there, so that is the combined structure, it is shown over here. So these are the some geometries or planes. Now here you can be able to now understand for this particular it will be at 200. This will be only with the x plane interception. This will be a cross plane interception from x to y, which is shown in the orange color. That is the Miller indices is 110. Then for the Miller indices 111, so this will be a plane for this. Okay, so almost now this terms has been cleared to you. So this will be an example for the interception of 111. So x from origin towards this x we have to travel by the 1 unit, then again to the z y 1 unit, and again to the z 1 unit. So in this way we have to draw the plane for the Miller indices 111. So these are some geometries which is shown over here, how to draw the planes. So for the 001 means only with the z plane interaction you have to, which is shown in the blue color. Then 100 with the x axis intersection, then this is with the only y axis, so this will be a 101. Then this is 110, 101 in the sense from 0 to 1, and only with the y it has to be traveled. So this kind of that slant edges are there with the parallel, or so there is no any intersection with the y axis. So this is with the 110, this is 01111, so this is 111, this will be a in the negative direction, so here we need to shift the origins. Okay, so I think you have enjoyed this particular